So in this video we're going to go over finding empirical and molecular formulas, and we can go ahead and start with the second question. So the first thing that I'm going to do is I'm going to go ahead and just write the symbols for the different elements that we have, and I'm going to go ahead and write fractions for each one. The numerator of the fraction is going to be the percent that we're given in the problem. So for carbon we have 22.88%. So I'm going to go ahead and copy that right here. And then in the denominator I'm going to get the mass from the periodic table and write it there underneath. For hydrogen we have 5.76 out of 1.01. And for arsenic we have 71.36%, but I'm just writing it without the percentage. And then out of 75, and we got that number from the periodic table. So now we do these calculation here. And we get 1.91. For the second one, 5.76 divided by 1.01 gives me 5.70. And then the third one I get 71.36 divided by 75.951. I'll keep that with 2 places after the decimal. Okay, so once we get these numbers, we want to divide the 3 numbers by the smallest one. So our smallest one is 0.95. So I'm going to go ahead and divide all of them by 0.95. And these are the numbers that we'll be using for the empirical formula, unless we can't round them. So we get some messy decimals that we can't round, then we'll have to rewrite them by multiplying all of the numbers by an integer that will give us whole numbers. So let's see what we get here. 1.91 divided by 0.95. So in the calculator I got 2 for this one. For the second one, 5.7.95. Get 6, so I'm getting nice whole numbers here. The third one is 0.95 divided by oh look, guess what? The third one gives me 1. Didn't even have to type that. And so we get very nice whole numbers, so we don't have to worry about rounding or anything like that. So now I'm going to have to write the empirical formula. So it's going to be C2, and then we have H6, and then arsenic, and that's just 1. And that is the empirical formula. Going back to the question, they want us to find empirical and the both of them, molecular and empirical. So I'm going to go ahead and box this here, and I'll put EF for empirical formula. Okay. So what we're going to do next is we're going to find the molecular formula, and all we have to do for the molecular formula is get this ratio. So molar mass, which is usually given in the question, so I'll put that here, given in question, divided by the mass of empirical formula. Okay, so when we find this ratio, when we divide this, we're going to get some number that we use to multiply all of the subscripts, and that will give us our molecular formula. Alright, so let's go ahead and do that here. So first I want to find the mass of this empirical formula, and we just have to add up these numbers, right? So for carbon we have 12, and then there are 2 of them, so 12 times 2 plus for hydrogen we have basically 1.01 times 6 plus, and then arsenic we used 75 times 1, so I'm not going to write it, I'll just leave it like that. So let's get the handy calculator, go ahead and multiply this. 1.01 times 75, okay, so we get, 105.06. Okay, so now we can go ahead and set up this ratio. So the molar mass is given in the question, and it is 210. So I put 210 there, and then the mass that we get from the empirical formula goes in the denominator. So that's 105.06. Now we divide these numbers. So 210 divided by 105.06, and we get approximately 2. So what we do now, it's actually pretty easy. We take this number and we just multiply all of the subscripts using this number here. So we get C4, H12, AS2. And then that would be the molecular formula. And that's how we do these. So let's go ahead and try the next one. Okay, so for number 3 it says nitrogen and oxygen form a series of at least 7 oxides with the general formula NXOY. One of them is a blue solid that contains 36.85 nitrogen. So I already see a percentage, so nitrogen 36.85, and then that's going to be out of, what do we have nitrogen in the periodic table? It should be 14. Let me confirm that real quick. Yes. So you get 14 here. And what else? So we have two things, and we know one of them, the percentage. We don't know the percentage of the other one, so we just have to subtract from 100, because I have to add up to 100%. So 100 minus 36.85, that means that we have, for oxygen, 63.15 out of 16. Okay, go back to the camera here. Alright. And that's all we have, right? So what is it? And we only need the empirical formula. So what we're going to do is first, like in the previous example, we go ahead and divide these numbers. So this is 36.85 divided by 14. And that gives me 2.632. And then for oxygen, I get 63.15 divided by 16. That gives me 3.947. Okay. So once we get these two numbers, then we have to divide them by the smallest one. Our smallest one is 2.632. So we know that this will give us 1. And then for the other one we have 3.947. I'll go ahead and write it just to be systematic. 2.632. 3.947 divided by 2.632. That gives me approximately 1.5. So this is a good example to kind of pay attention to these numbers. So we can't write these numbers right away in our answer because they're not all whole numbers. Once we divided these, we got 1 here and we got 1.5. So what we need to do is multiply both of them by 2 so that we get whole numbers, because 1.5 times 2 is 3, and 1 times 2 is 2. So now we have whole numbers, and we're going to write them as our subscripts. So we have N2O3. This is the empirical formula. Alright, so that's number 3. I can do number 4. I'll put it on the side over here. Alright, so I'm just going to kind of get to the important part here. A sample is found that contains 14 point blah 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 grams of carbon, blah 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 grams of hydrogen, and grams of nitrogen. Its molar mass is 102.2 grams per mole. Determine the molecular formula. So what we need to do here is we need to find, again, the mass per mole. So I'm going to go ahead and copy down the different elements that we have here. So we have carbon, and then we have hydrogen and nitrogen. And then the numbers they give us are 14.693 grams. So that's for carbon, and then that is out of, we're going to put 12 here, and then we have 3.453 hydrogen. And for nitrogen we have 6.855. Okay, so in terms of the mass, we're going to add these up. Actually, let me go ahead and write it like this. So we're going to add up the numbers. We get 14.693 plus 3.453 plus 6.855. And this represents the total mass. So we can get these percentages here. So 25.001. So I'm going to write these in the denominators so that we can get the percentages for each thing. So I'm going to go ahead and put this on the side. I'm going to put percentages. We want to find that first. Okay, so we get 14.693 divided by 25.001, and that gives us 58.77%. So I'm going to go ahead and write that here. 58.77% for carbon, and then for hydrogen we have 3.453 divided by 25.001, and then as a percentage that gives us 13.81%. And then for nitrogen we have 6.855 divided by 25.001, and that's going to be 27.42%. Okay, so now we can go ahead and use these numbers and the numbers we get from the periodic table to find that ratio. So let's go ahead and do that here. 58.77 out of And then for carbon we have 12. For hydrogen it's 13.81 out of 1.001. And for nitrogen it is 27.42 out of what was it, 14. Alright, so now we can go ahead and divide all of these. We get 58.77 divided by 12, and that gives me 4. I'm going to use 3 decimal places for these. So 4.898. 898, yeah. 13.81 divided by 1.001. And this gives me 13.796. Alright. And then for the last one, we have 27.42 divided by 14 is 1.959. 959. Okay. So now that we have these numbers, we're going to go ahead and divide them using the smallest one. So our smallest one is 1.959. So all these get divided by 1.959, 1.959, and 1.959. Okay. So here we get 1 for the first one. Let me type that here. 4.898 divided by 1.959. So I get 2.5 here. And for the second one, I get 13.796 divided by 1.959, and that's 7. Okay. So again, these are not all whole numbers. So we need to make them whole numbers. So we're going to multiply everything by 2 so that this turns into a whole number. So 2.5 times 2 is 5. And then here we get 14, and then 1 times 2 is 2. So then for our formula, and this is the empirical. So I'm going to go ahead and do I'm going to write the empirical, but I'm not going to box it since it's not the answer to the question, because we have to jump to get to the molecular formula. So we'll put C5, H14, N2. Okay, so that's the empirical formula. So I'll put empirical right here. So remember that when we're finding molecular, we need to find the mass of the empirical formula, because the formula that we use for the molecular is the ratio of molar mass, which is given in the problem, over or to empirical formula mass. Alright, so let's go ahead and do the empirical formula mass on the side over here. So emp form mass. So we're just going to do 5 times 12 plus 14 times 1.001 plus 14 times 2, and we get 102.014. So now I can go ahead and set this up. The molar mass they give us for this question is 102.2. Aha! 102.2. And then our empirical formula is 102.014. So when we divide these, we're going to get a number that's very, very close to 1. Divided by 102.014. Yes, so we get 1. What that tells us is that we use this number, multiply all of these by that. So in this question, our empirical formula is the same as the molecular formula, since we're multiplying the subscripts by 1. So essentially all the numbers stay the same. So then this is the molecular formula. So this is a coincidence, but it happens where the empirical formula is the same as the molecular formula. Alright, so we got that. Now I can move on to number 5. go ahead and jump to that one. Some pure powdered copper metal. So here they're giving you the mass is heated in a stream of oxygen to give 1.33 pure oxide, blah, blah, blah. So CuO, what is the empirical formula? So what we need to do first is find percentages like the previous question. So the different elements we have here are oxygen and copper. So I'm going to put here oxygen and copper. To find the percent for oxygen, we have to write, let's see, powdered copper metal. So we have to do copper first. We have 1.056 grams of the copper part. So this copper is 1.056. And the copper oxide is the other number, the 1.322. 1.322. So we can use that to find this percentage, and then that will tell us what the other one has to be. So 1.056 divided by 1.322. So this is telling me that 79.88% is from copper. So 79.88. So if that's from copper, then we have to do 100 minus that number to get our percentage of oxygen. So this is the percentage for copper. The percentage for oxygen is 20.12%. Alright, so we got that. Now we can go ahead and find the mole numbers using the periodic table. So we have 20.12 out of, for oxygen we got 16, and then copper is going to be 79.88 divided by, now I can go to the periodic table, so copper, and that is 63.55. Okay. So let's go ahead and compute this, see what we get. 20.12 divided by 16, 1.2575. 2575. And then for copper, we got 79.88 divided by 63.55, 1.25696. So I'll round it to 1.257. 1.257. So now we divide both by the smallest one. In this case it's 1.257. So this is going to be, actually, let me see something. Yeah, I'm rounding it, but it's going to be pretty much 1. So we're going to 1.257, and then over here 1.257, see what we get. So this one is 1. The other one's going to be super close to 1. Divided by 257. Yeah, it's 1.0004, which is basically just 1. So now that we have that, these are the numbers that we're going to go ahead and write. So it's just CuO. Because a subscript here, you don't put a 1, it's understood to be a 1. Okay, so then this is the empirical formula, and that is all we need to find for that one. And we have one more question, which is number 6. Let's go ahead and get to that. It says, give the empirical formula of each of the following compounds. So for vitamin C, we have C6. So remember that the relationship between molecular formula and empirical formula is that empirical formula is the smallest integer multiple for all of the values. So in a sense, it's like simplifying or reducing fractions. So all of these numbers can be divisible by, or are divisible by 2. So this can give us C, and then 2 goes into 6 3 times, and then H goes 2 goes into 8 4 times, and then 2 goes into 6, sorry, 3 times. So then this would be our empirical formula. So in a sense, we're going from the molecular formula to the empirical formula. That's what's happening in these questions. So like benzene, if you look at the next one, this is C6, H6. So you can divide both of them subscripts by 6, and then you get CH. And then that would be the empirical formula. So that's all you have to do for those. So you just want to simplify them down. And that is the last one, because I don't think we have to do number 7.